Let's do some guided practice for section 3.2, product and quotient rules. We're going to differentiate, well, each of the following, right? F prime of x, right? We've got this component and that component, right? Take the derivative of the first part, leave the second guy untouched, plus leave the first guy untouched, times the derivative of the second guy. Done. You could simplify that if you want. Why not? Let's just simplify really quickly. We're going to get 2x to the fifth. This one isn't so bad. Usually I wouldn't simplify, but this is not that bad. It's all a bunch of just polynomial stuff, right? So, anyway, foil this. Be a little careful when you foil. Hopefully I won't make a mistake. Pretty sure I did that correctly, right? Let me clean it up a little bit. We get 6x to the fifth. I don't think we have any x to the fourth terms. No, so I guess we just have plus 4x cubed plus 9x squared as minus 2x plus 3. Right, so I think we've got that, right? So, usually I won't ask you to simplify if it's something really complicated. This wasn't so bad, right? Anyway, here we got this, lovely. Same thing, right? We take the derivative of the first. Now remember, the square root of x is x to the 1/2. So the derivative is going to be 1/2 x to the negative 1/2, or 1 over 2 root x. If you don't see that simplification, then pause, right? Note that this is the same as this. Right, anyway, we do that. Remember, the plus 2 goes to 0. We leave this guy alone. And now, plus, leave this first guy alone, and take the derivative of this guy. Now, you could simplify this if you wanted, but it'd be a mess. You're going to have a root x in the bottom, a root x in the top. I don't really think it's worth it. So remember, in general, on a quiz or an exam, simplify it if and only if I ask you to. All right, now something like this, f of x equals 3x over x squared plus 1, right? We're talking quotient rule here, right? Remember, we've got the top and the bottom, right? Low d high minus high d low, right? Low d high minus high d low all over low squared. Now, this one I do think is quick enough we can simplify. One way you should not simplify, I see students do this sometimes. They just go like, oh, look, I can take this out, and we're good. No, you cannot. You'd also have to divide this by x squared plus 1, right? You can't automatically simplify, right? You have to be a little bit more careful. So anyway, we can simplify this, though, somewhat, right? Multiply the 3 by the x squared plus 1, becomes x squared plus 3 minus 6x squared, and we get this x squared plus 1 squared term on the bottom, right, of course. Simplify that a little bit more. Those will become negative 3x squared plus 3, x squared plus 1 squared, right? And then you could factor out a negative 3 if you want, I guess, right? You get negative 3 times x squared minus 1 over x squared plus 1 squared. Yeah, you can't really simplify it any more than that, can you? So, can't really factor anything. So that's what we've got. All right, and then in this case, right again, low d high, right? It's good to write f prime. One thing I'm going to say, please write f prime of x equals, right? So I know exactly what you're doing. I know what you're doing, but still, please just write f prime of x equals minus high d low all over low squared. Now again, we can simplify this a little bit. This isn't too bad. It's gonna be a little nasty with the, well, it's not really that bad. Let's see. We're gonna have 3x, I'll write this out, 3x over 2 root x minus 2 over 2 root x. Everyone see how I got that? Minus 3 root x. All right. All of this divided by, of course, the bottom squared. Now we can simplify this a little bit more, right? So we get 3/2 root x minus 1 over root x minus 3 root x. And all of this, of course, is over 3x minus 2 squared. Right, and then we can keep simplifying a little bit more, right? 3 halves root x minus 3 root x, right? That's going to be negative 3 halves root x minus 1 over root x all over 3x minus 2 squared. We can actually go a little bit more, right? If we multiplied the top and the bottom of this big fraction, right, by root x, right, do that. The bottom's not going to be quite so bad, right? We get a root x in the bottom, an additional root x, right? It's going to be equals whatever the denominator is, right? It's going to be root x times what we had before, right? Not so bad, right? But the top will be a little bit nicer, right? Because we're going to get negative 3 halves root x times root x, right? Root x times root x. What's that going to equal? It's going to be x. Make that a little nicer. X minus 1. Right? Because 1 over root x times root x just becomes minus 1. That is a lot nicer than what we had before. So we're just going to do that. And I think at this point, well, I guess if we were very clever, right? What if we multiply the top? Oh, yeah, no, I actually don't think we can. Can't reduce this anymore. Can't reduce this anymore. But if you didn't like that repeated fraction, then maybe you could multiply the top and the bottom by 2. And we're going to get, again, you don't need to do this, but if you did, you get negative 3x minus 1 over 2 root x times 3x minus 2 squared. All right, so you get that. All right, and that's what we've got.